Okay, guys, so we're gonna use this formula again that we used before for the equation of a tangent line. So recall this: the equation of a tangent line to a function f of x at some number a is y equals f of a plus f prime of a, and then in parentheses, times x minus a. So let f be the function defined by this. If g is equal to f inverse, so they're telling you that f and g are inverses, and f of 1 equals 7, find the equation of the tangent line to the graph of g at x equals 7. All right? So anytime they're asking you for the equation of a tangent line to, the graph of some function, use this formula, but we're going to use g instead of f, and it's going to be 7 instead of a. So plugging into the formula, we get y equals g of 7 plus g prime of 7 times x minus 7. So the two things that we need to find here are g of 7 and g prime of 7. Okay. Now, the fact that f and g are inverses is going to, come into play here. It's going to help us find both of these things. It's going to help us find g of 7 because we know f of 1 equals 7. And if f and g are inverses, then we can also say that g of 7 equals 1. Okay, because f and g are inverses. Okay, so that's how the inputs and outputs, work. They switch places. All right, now we need g prime of 7. And again, because g is equal to f inverse, they're inverses, we've got this formula. So we know that g prime of 7 is 1 over f prime of g of 7. And we just said what g of 7 was. So f prime of 1. That happens a lot, it seems, 1. And then we just need to find f prime. All right. So this kind of all is like an aside, but let me do another aside here when I find f prime. So f prime of x is equal to 21x squared plus, guys, for the natural log to the third, you need chain rule, okay? You need chain rule. So, I don't know, where should I do it? I guess I'll do it like here, in, out. The inside is natural log of x, the outside is blank to the third. Oh, you couldn't even see that. Blurry. Okay, so the derivative of the inside is 1 over x, and then the derivative of the outside is 3 blank to the second, and then natural log of x goes back in there. Okay, then, okay, so I'll be like this. So then we've got f prime of 1 equal to 21 plus, that's just 1 over 1 times 3 natural log of 1 squared. Guys, the natural log of 1 is 0. All right, that is something that we just need to be really fast about. All right, so like if you ask yourself, the natural log of 1, suppose you don't know what it is and you let it like equal something, a. Convert this to exponential form. Okay, that base is e, so it'd be e to the a is 1. Well, what's a got to be if it's an exponent and you end up getting 1? It's 0. All right, so anyway, it's better just to know that this is all 0. All right, so that's going to be 0. All right, that whole thing is 0. So it's just 21. All right, so this is 1 over 21. So now I go back to here, so y is equal to g of 7 is 1 plus 1 over 21 x minus 7. Okay, so there we have it. That is the equation of the tangent line. Okay, now we've got another one. Okay, so these functions f and g are differentiable, means that you could take their derivatives, for all real numbers, and g is strictly increasing. Now, if you remember from before, when they say g is strictly increasing, they're just like, that's a way of telling you that g has an inverse function, okay? If g were not strictly increasing, maybe it doesn't have an inverse function. So, but that's okay, guys. It's a little bit like, I mean, it is important information, but you could still do the problem if you didn't know it, I guess. It just, like, the logic might not be super tight. But that's okay. So the table below gives values of the functions and their derivatives at selected values of x. If this is the inverse function of g, write an equation for the line tangent to the graph of y equals g inverse at x equals 2. Okay, now you know how before, we would let g equal f inverse? Well, maybe now we should let f equal g inverse. Okay, so I'll be like this. I'll be like, let f of x equal g inverse of x. So we want equation of tangent line to f of x at x equals 2. All right, so we're just switching notation so it's easier to work with. So anytime they say equation of tangent line, it's different than the slope of the tangent line. If they say the slope of the tangent line, they just want the derivative. But if they say the equation of the tangent line, they want you to use this formula. Okay, so I'm using it. Y equals f of 2 plus f prime of 2 x minus 2. Okay. I need to know what f of 2 is. All right, so I could think like this. I guess aside. Okay, so I want f of 2. So f of 2 equals, I want to know. Well, you know how inverse functions work, like their inputs and outputs are switched. So really, what I'm looking for, if I'm looking for the output that an input of 2 gives me on f, that's the same as looking for the input on g that corresponds to an output of 2. And I actually know this from the, yeah. So what input on g is going to give me an output of 2? It's right here. It's right there. So from table, we have g of 1 is 2, so that means that f of 2 is 1. All right, so there I've got that. And now for the f prime part, okay, here's another, I'll do another little aside. Oh my gosh, it doesn't even look like the word aside. Okay, so for f prime of 2, f prime of 2 is 1 over g prime of f of 2 equals 1 over g prime of f of 2. I already found out was 1. 1 over g prime of 1. So there's the g prime values. G prime of 1 is 5. So 1/5. And now I just plug these things in. So y equals 1 plus 1/5 times x minus 2. That is the equation of the tangent line to the inverse of g, which I named f, at x equals 2.